Last week we talked about two major kinds of statistics. Remember that we look at data using both descriptive statistics, which are meant to describe the data, and inferential statistics, where we're trying to draw conclusions or make generalizations. This week we're going to be really focusing on descriptive statistics. So the first kind of descriptive statistic that exists are tables and graphs. So essentially tables and graphs are meant to help us see the data a little bit more clearly. The first kind of table that the textbook talks about is a frequency distribution table. And essentially what a frequency distribution table does is it organizes the data based on how often that data point occurs. So it's essentially a table that shows the frequency, how often the data occurs. The textbook does a really good job of showing how to create these, so I'm not going to spend a lot of time on them. Other than a table, we also look at graphs, and graphs actually are probably the most useful kind of visual aid that we use in statistics. And the textbook describes a lot of different kinds of graphs, but the one that I want to talk about, and the one that is going to be the most important for this semester, are the histograms. And here we have an example of a histogram. And a histogram is essentially a graphic version of a frequency distribution table. You can see in our example here that there is frequency running up the y-axis. So this graph shows us how often each of the data points on the bottom, number of weeks, occurs. So there's a couple of 1s and 2s, more 3s, quite a few 4s, fewer 5s, and very little 6s. Now, the most important kind of distribution, frequency distribution, that we'll talk about, and we'll talk about it quite frequently in the next few weeks, is the normal distribution, sometimes referred to as the normal curve. Other people will call it the standard distribution. And essentially, a normal distribution is a symmetrical distribution where a majority of the data falls in the center and a few other data points fall towards the extremes. Other than being a normal distribution, there's a couple other shapes that are important to note. The first is that sometimes the distribution might be skewed. So we can see both on the left and the right that a majority of the data do not fall in the center. They actually fall to the left in the picture on the left, and the majority falls to the right in the picture on the right, and that makes this a skew. A skew is important because when you have skewed data, your mean is probably not the best central tendency measure, and we'll talk about those in a minute. Another kind of distribution that we might see this semester are bimodal distributions. And a bimodal distribution is essentially a distribution that has two humps. A unimodal distribution is what we could call the normal distribution. But here in this picture you see that essentially it looks like a camel's back. There are two modes, two peaks. So I mentioned the mean and I mentioned the mode. Those are examples of measures of central tendency, and this is a kind of descriptive statistic that's meant to find a single score that best describes a distribution. So instead of looking at a picture of the data, we're now going to actually look for one number that best represents the data. And the kinds of central tendency measures out there are the mean, median, and mode. Hopefully these are ideas that you have run across at least at some point previously in your education. So the mean is the average, and we can either have a mean for the population or a mean for the sample, depending on what we're dealing with. The mean for the population, or the average for the population, is given by this little character called the mu, and what you do to find the average, or the mu, is you take all of your data, add them up, remember our little summation notation there, the m on its side, and divide it by the number of data points that you have. Or if you're talking about a sample, we either call it the mean with a capital M or X bar is how that's referred to. Both of those are symbols that represent that this is a sample average. And to find that mean, the sample mean, you would sum up all of the data points and divide it by the number that you have. The next is the median. And the median is a score that cuts a distribution in half, so the very middle score. Think about the median as the strip of land that runs down the freeway in between, in the middle of the two directions. So in order to find the median, what you would do is you would list out your values in numerical order, and for however many you have. So if you have 4 of the data point 10, you would actually write 10 4 times. You don't just write it once. It needs to go in numerical order counting up, or you could actually count down too, but it all has to be in order. So if you have an odd number of scores, what you do is you just find the actual middle score, and that's your median value. If you have an even number of scores, you would take the two middlemost scores and average those. So add them together and divide by 2, and that will give you your median. The mode is last, and it is the score that occurs most frequently. So we already talked about the bimodal distribution, and that is a distribution that has more than one mode value. So remember that graph we saw just a minute ago that had two humps? It had two modes. And in order to do this, you would look at your frequency table for the number that occurred the most often. So one question that you want to ask is, when should I use any of the specific measures of central tendency to report to someone? Because my goal is to give them an idea of my data with one number. And we want that one number to be the best representation of the data possible, but we have three to choose from. We have the mean, the median, and the mode. So I want to talk for a few minutes about when each is the best option. So first, starting with the mean. When is the mean the best option? The mean is the best option when you have interval or ratio data that's normally distributed. And it's also the one that is used the most commonly. So you probably have seen the mean before or heard about the average score before because it's the one that we use the most. But there are a couple times when the mean actually wouldn't be the most useful. The median would be better if you have ordinal data and if there's a skew in your distribution, because what happens to the mean is that when there's a skew, it means that there's some outliers pulling the data one direction or the other, that is causing the mean to be biased, and so it's actually not the most reflective number. The median, however, would be a good distribution value to report in the case that you had a skew. And finally, the mode is best if you have nominal data, and especially if a distribution is bimodal. So even if you've got interval or ratio data, but there are two modes or two peaks in the data, you would go ahead and report the mode, or the modes in this case, there would be two.